Hello everyone, welcome back to Geeks for Geeks. So today we are going to discuss problem of the day, that is find all triplets with zero sum. Okay, so let's quickly have a look on the problem statement. So our problem says that given an array ARR, find all possible indices I, j, k of triplets, array of I, array of j, array of k in the array whose sum is equals to 0. Okay, what is the meaning of this line? So basically we are given an array and we have to find all the possible indices that are I, j, k of triplets such that the sum of the values that are present on these indices is coming out to be equals to 0. Okay, return the indices of triplets in any order and the returned triplets should be also internally sorted. What is the meaning of this line? So basically we have to sort the indices internally. It means that if we have three indices, then I have to sort them on the basis of their digits. Okay, so that is the meaning of this line, that we have to sort them internally. That is for any triplet indices I, j, the condition should be hold. Okay, so that is the real meaning of what is the meaning of internally sorted. That is the real meaning of internally sorted, that I should be lesser than j and j should be lesser than k. Okay, so this condition should be followed by these three indices. Okay, so that is the problem statement. Let's see by using the example number 1 that is given to us, right? So this is the example that is given to us. So we are given array as 0, -1, 2, -3 and 1. Okay, so we are given this array and we have to find out if there are any possible indices I, j, k such that their sum is coming out to be equals to 0. Okay, so here we have three triplets. So we have two triplets. So the first triplet is 0, 1, 4. So what is the meaning of this 0, 1, 4? It means that the value that is present on the 0th index and the value that is present on the first index and the value that is present on the fourth index. So the sum is coming out to be equals to 0. Okay, so let's see if it is equals to or not. So here you can see that array of 0 is 0. Okay, and array of 1 is -1, so we have written a -1 here. And what is the value of array of 4? So array of 4 is +1. Okay, so that's why we have written 0 plus -1 plus 1. Okay, so what is the sum of these three numbers? So here you can see that the sum of these three numbers is coming out to be equals to 0. So that's why I can say that this can be one of the possible triplet of indices 0, 1, 4. Let's see what is the second triplet that is given to us. So the second triplet is 2, 3, 4, right? So let's see what are the values that are present on 2, 3, 4. So array of 2 is equals to 2. So that's why we have written a 2 here. And what is the value that is present on the third index? So the value present on the third index is -3. So that's why we have written a -3 here. And what is the value that is present on the fourth index? So it is equals to 1. So that's why we have written a 1 here. So 2 minus 3 plus 1. So what will be the total value? So the total value will come out to be equals to 0. Okay, so that's why for this given example number 1, we only have these two indices. What is the first pair triplet of indices? So it is 0, 1, 4. And what is the second triplet of indices? So it is 2, 3, 4. Okay, so that's why in the answer we have to return these triplets. So let's see if the answer is equals to or not. So here you can see that in example number 1, the output is equal. That is, the first triplet is 0, 1, 4 and the second triplet is 2, 3, 4, right? So that's why we have to return 0, 1, 4 and 2, 3, 4 from the question from the function. Okay, so I hope the example and the problem statement is clear to you. So let's quickly move to the approach. Okay, so first of all, we are going to see a brute force approach, right? So brute force approach is very simple. So what we can do? So we can use three for loops here, because if I use three for loops, then I will be able to generate all the possible indices I, j, k. Okay, so that will be the first approach, or what we can say, that can be the brute force approach, right? So let's see how we can let's see what is the pseudocode. So how we are going to implement this. So that's the pseudocode for the brute force approach, right? So this is the brute force approach. So what we are doing here? So first of all, we are running a for loop from 0 to n, and we are taking index I. So outer for loop is having index outer for loop is running n times. Then inside this we have another for loop. So that for loop is for j. So j is also running from 0 to n, and inside this we have another for loop, that is k, that is also running from 0 to n minus 1, right? So basically we have three nested for loops here. So by using three nested for loops, by using these three nested for loops, we will be able to generate all the possible combinations of triplets, that is I, j, k. Okay. So that's why we are using three for loops here, and inside this we have one if condition, that if the sum of the values that are present on index I, j, k is equals to the sum. So in that case, what we have to do, we can say that these are the possible triplets or the possible answer for this given question. Okay, we can have multiple indices. Okay, so this can be the one possible answer. So that's why we are checking if array of I and array of j and array of k is equals to sum, and also they should not be duplicate. It means that I should not be equals to j should not be equals to k, and k should not be equals to I. Okay, so that's why we are again checking this, that they should not be equal. So after that, what we are doing, so here we don't have to push back the values. So instead of pushing back the values, we have to take care of the indices. So that's why we will be pushing back the indices I comma j comma k. Okay, so answer will be the answer vector. So I will store I comma j comma k vector into the vector of vector, that is answer. Okay, so that is the very first brute force approach that you can think, right? Okay, so let's discuss the time complexity. So the time complexity would be order of n cube, not order of n, it would be order of n cube. Why? Because we are running three nested for loops, and every for loop can go up to n, can run up to n times. So they are also in nested form, so that's why the time complexity would be multiplied. So the time complexity would be order of n cube. But here we can see in the constraints, that is array dot size can go up to 10 to the power 3. So let's say if I am denoting array size as n, so it can go up to 10 to the power 3. So if I try to use this, so what will be the value of n cube here? So it will become 10 to the power 9. So it will become order of 10 to the power 9, which is high. So that's why it would lead me a TLE, because we can only perform 10 to the power 7 or 10 to the power 8 operations in 1 second. But here, by using this solution, we are performing 10 to the power 9 seconds. So that's why we will be getting TLE, right? So that's why we have to think of some optimized approach, right? So let's discuss how we can solve this using optimized approach. Before moving to the optimized approach, this problem is kind of similar to the two sum problem. Okay, here we are going to use a hash map here. So okay, so let's discuss the optimized approach. So basically in the question, what we are trying to find out, we are trying to find out these three values, that is a, b and c. We are trying to find out these three values such that the sum of these three values is coming out to be equals to 0. Okay, so if I try to use this as a mathematical equation, so we will be having this, that is a plus b plus c is coming out to be equals to 0. Okay, so that will be the mathematical equation. So basically we have to find out the indices of a, b and c, and the values that are present on those indices, and the sum of the values that are present on those indices is coming out to be equals to 0. Okay, so that thing we have to find out, right? So here what we can do, so we can modify this equation, because suppose if I take this c and make it to the right side of the equation. Okay, so what we can do, so we can just simply take a and keep a plus b on the left side of the equation, and I am just putting minus c on the right side. Okay, so if I try to move my c to the right side, then my equation will be looking like this, that is a plus b equals to minus c, right? Okay, suppose you are able to find out the value of a and b. So if you are able to find out the value of a and b, so will you find out the value of c? Yes, definitely you can find out, because if you try to sum a and b, just add a minus sign. So that's how you will be able to find out the value of c. C will become equals to minus a plus b, right? So here we, as we can see that I if I am able to find out the values of a and b, then from those values of a and b, I can easily find out the value of c. So that's the main thing that we are going to use here, right? So what we can do, we can run a for loop to find out the value of A, and we can run inside inner for loop to find out the value of J. So how we are going to find out? So we will be using a for loop for A, and we will be also using the for loop for J. So by using these two nested for loops, I will be able to find out the value of A and B. Right now, I have to find out the value of C also. So how will I find out? I will just do the sum of A and B and add a minus sign before the sum. So that is minus A plus B. I will be easily able to find out. So now the main thing is that how you are going to find out the value of C, right? So here comes up the map. So in map data structure, to find out if that particular element is present or not, so it has the average time complexity is order of 1. Okay, so we are going to take the advantage of that time complexity. So what we will do, we will just try to put the every value of the array and its index into my map. So I will try to put the value key as a value in map. Key will become the value of the array, and what will be the value? So value will be the index. Okay, so what I will try to do, I will try to put the value and index into my map data structure. I will be easily able to get the element in average time complexity as order of 1, right? So here we are using a for loop to find out the value of A and B. So I will be easily able to find out if C is present in my map or not. So if C is present, C, what is the value of C? So value of C is minus A plus B. So what we can see here, so basically I can find out the value of minus C if it is present in my map or not. So if it is present, then I can say that I will be able to get this equation, that is A plus B plus C. I can say that these three values are present into my map, so I can just easily find out what are the indices of these three values, and I can just simply add them to my data structure, right? So let us see how we are going to use this map thing. Okay, so I have taken this example, that is example number 1 again. Okay, so what we are going to do, so basically we will be using two for loops. So I will be the outer for loop and J will be the inner for loop. So I will find out the value of A and J will find out the value of B. Okay, so for I is equals to 0, so when the value of I is 0, my inner for loop will run n times because these are nested. So here initially the map is empty, so this is the map data structure. It will store the values like this. So it will store the value, and what will be the value of this value? So it will be the index. Okay, I'm going to store the values like this, value and index. Okay, so when I is equals to 0, this j for loop will run n times. So I is 0, what is the value of j value is 0. Okay, so here we are going to ignore the value because I and j are similar, so we are not going to take uh, j is equals to 0 here. So we will be starting from j is equals to 1. So when I is equals to 0 and j is equals to 1, so what are the values that are present into these indices? So it is 0 and minus 1. Okay, so here we have got two values. Now how to find out the third value? So the third value will be the sum of these two values, and I will add a negative sign before that. So 0 minus 1, that will become minus 1, and if I try to add a minus sign before, so it will become 1. Okay, so that's why it will become plus 1. So now I will try to find out if plus 1 is present into my map or not. So here you can clearly see that there is no value present in my map, so that's why we are not going to take these two indices as the answer, and move to the next index, that is j is equals to 2. So array of I will be equals to 0 and array of j, it is 2. So what will be the value? So the value that I'm going to find out into my map is minus 2. So here we can clearly see that minus 2 is also not present. Move to the next index. So the next index is 3. So that's why 0 minus 3. What will be the sum? So sum will be 3 minus 3, and I will add a minus sign. So it will become 3. Okay. Here we can clearly see that 3 is also not present. So move to the next index, that is 4. So 0 comma 1. So sum will be 1, and I will add a minus sign. That will become minus 1. So minus 1 is also not present into my map. So I will move to the next iteration of I. Okay, before moving to the next iteration of I, what I am going to do, I am going to put the current value into my map data structure. Okay, so here the current value is 0, so I will put 0 and its corresponding index. So its corresponding index is also 0. So 0 corresponds to 0 index. Okay, now move to the next iteration of I. So I value is 1. So we are not going to take this j value is equals to 1 here, because j value and I value becomes equal, right? So I value is 1, j value is 0. What are the values that are present at these particular indexes? So it is 0 and minus 1. So 0 and minus 1. So the sum is coming out to be equals to, here we can clearly see that 1 is also not present. Move to the next index. So we are at j is equals to 2. So what is the value that is present at index 1? That is minus 1 and 2. So minus 1 comma 2, what is the sum? Sum is minus 1, sum is 1, so it will become minus 1. Is minus 1 present? Not, it's not present. Move to the next iteration of j. So j becomes 3, so minus 1 comma minus 3. Minus 1 comma minus 3, what is the sum? Sum is minus 4. Add a minus sign before 4, so that will become 4. Is 4 present into my map? It's not present. Move to the next iteration of j. So minus 1 comma 1. What is the value of minus 1 comma 1? Minus 1 comma 1, what will be the sum? So it will become 0. So if I try to add a minus sign before 0, that will also remain 0. Oh, okay. So here you can see that we have got a sum as 0, and this sum 0 is already present into my map. So when this thing happens, where here we can see that minus 1 comma 1 comma 0, so we have got three values, and the sum of these three values is coming out to be equals to 0. So in that case you can say that I have got one triplet that is summing up to be 0. Okay, so what is the triplet? So the triplet is minus 1, 1 and 0. Okay, so this is the triplet that is minus 1, 1 and 0. And what are the indexes? So in the first index is this one, 1. And what is the second index? So the second index is j. First index is I, second index is j, that is 4. How to get the third index? So the third index I can get from the map data structure, because for every value I have mapped that with its index. So its index is 0. So 0th index is 0. So here we have these three values. So if I try to sort this, so it will become 0, 1, 4. Okay. So it means that the first answer or the first triplet that we have got is 0, 1, 4. Okay. So here you can also see that the first triplet in the given example is also as 0, 1, 4. Okay. So here we can see that how we are going to use this logic. So that is the first index. So if I try to use this now, okay, so if I try to move to the next iteration, so my map will look like this. I have put minus 1 and its corresponding index into my map data structure. So I becomes equals to 2. So when I is 2, j value is 0. So we have got 2 comma 0. So the sum is coming out to be 2, and negative sign we have to add. So that is minus 2. So minus 2 is not present. Move to the next iteration of j. So j become equals to 1, and here j become equals to 1. So what will be the sum? So sum will be 1, and if I have to add minus sign before that sum, so that will become minus 1. Okay, here you can see that minus 1 is already present. So we have got another triplet. What are the indices? So the indices are I and j. So indices are 2 comma 1, and I have to find out the index of the value minus 1 from my map data structure. So here you can see that index is coming out to be 1. So I will have to write 1 here. Okay, so here you have to note one thing, that here the two indices are coming out to be equal, that is 1 and 1, but the value that is present on index 1, we are only going to use that value one time. So that's why this is not a valid triplet. Why this is not a valid triplet? Because 1 is getting duplicated, right? So we will move to the next iteration. Okay, so I will try to put that values, and I will try to check if it is present or not. So if I try to move to the next iteration of I, so that will look like this. So before moving to the next iteration, I will try to put the current value of array of I into my map. So it will become map will become 2, and its index is also 2. Okay, I will move to the next iteration of I, that is minus 3 comma 0. So the sum will become the resultant sum that we have required is 3. Is 3 present? It's not present. Minus 3 minus 1, that is minus 4, and minus 4 will become 4. Is 4 present? No, not present. And move to the next value, that is minus 3, 2. Minus 3 plus 2, that will become minus 1. So it will become 1. 1 is present, it's not present. Then minus 3 plus 1, it will become minus 2. Minus 2 will become 2. So is 2 present? Yes, 2 is present. So let's see if they have the different indices. So the first index is I, so that is 3. The second index is J, that is 4, and the third index is 2. Okay, so here you can see that we are getting three different indexes, that is 3 comma 4 comma 2. So here we can see that this is a valid triplet, and I will try to sort them, so it will become 2 comma 3 comma 4. Okay, so it means that the values that are present on 2, 3 and 4, these particular indexes, is coming out to be the sum is coming out to be equals to 0. Okay, so here you can also see that we have got answer 2 comma 3 comma 4. Okay, so that's how we are going to solve this. So let's quickly try to code this up. Okay, you can also do the dry run for the iteration is equals to 4. Okay, so we will quickly move to the coding part. Okay, so first of all we need a hash map to store the values. So I'm taking one hash map integer. We are also going to take a set. Why we are going to take a set? To keep the duplicates, to keep the unique values. Okay, so I'm going to use a set as st, and we are going to use two nested for loops. I, so I is to find the value of a, and j is to find out the value of b. Okay, and inside this we have to use another for loop for j is less than n and j plus plus, right? First of all we have to define what is the value of n. So array dot size is the value of n, right? So what is the value of a? So a is array of I, and what is the value of b? B is array of j. Okay, now what is the value of c? So c will be the value of a plus b, and we have to add a minus sign before a plus b, right? Now if map dot count C is equals to 1. What is the meaning of this line? It means that C is present into my map. So if it is true, and I should not be equals to J, and J should not be equals to K, and K should not be equals to I. Okay, we have to keep this in mind that these three indices should be unique. Okay, so if this condition is true, what can I do? I can make one vector. Let's say I'm making a temporary vector of 3 size, and temp of 0 I am putting the value I, and temp of 1 I am putting the index j, and temp of 2 I am putting the index of this c value, that is map of c. After that I have to sort this temporary vector. So temp dot begin, because it is given in the question that we have to internally sort these triplets, temp dot end, right? Now I will add this temporary vector into my set data structure so that I have unique triplets. Okay, so st dot insert temp, right? Okay, now after this for loop is finished, I will have all the possible triplets that are coming out to be the sum that is coming out to be equals to 0 stored into the set data structure. So in the end you just have to take out the triplets. So let's say I'm taking one answer vector, and I will just iterate on this set st, and just push back the uh, vector that is present on that iterator. So answer dot pushback it, and in the end just simply return this answer. Okay, so let's see if the code is passing, or compile and run. Okay, so we are having, okay, so here we have to add a semicolon. Okay, let's see if it is running or not. Okay, so we have got another compilation error. Okay, so K, so basically we have to use map of C here instead of K. The index is map of C. It is stored into my map data structure. Okay, so we just missed one line, that is we have to put the values into map also. So map of array of I is equals to I. Okay, so let's see if it's running or not. Okay, so now it's working fine. What was the mistake? So at line 26 we missed to put the value array of I into my map data structure. Okay, now let's try to submit if it's working or not. Okay, so yeah, it's working for all the test cases. Let's quickly discuss the time complexity. So here you can see that we are using two nested for loops. So the time complexity would be order of n square, and inside these two for loops we are just checking if the value is present in my map or not. So if we take the average time complexity of that value as order of 1, so the overall resultant time complexity would be order of n square. and that would pass these constraints. Okay, so I hope you find this video helpful. Okay, thank you for watching the video.